Okay, we're going to cover this a little bit more in depth here. Not a terrible amount of depth, but I really want to hit home the idea of the whole shim ratio, okay? So we're going to pretend that this is a pump, okay? And pardon my penmanship here, and this is going to be the motor. And remember, we talked about it. Usually it's going to be the pump that's stationary, and the motor is going to be the movable one, but it doesn't really matter. This is the stationary over here, and then movable. Okay, so in other words, whatever we're checking, we're going to be actually doing the adjustments over here and not the over here. So when we go to take a look for vertical alignment, we're going to pretend that this is a straight line over here, and it's going to go up like this, but it's going to be parallel with this surface. And then by measuring a point here and here, okay, we can see that this right here is a larger circle than this one, so therefore this is going to have a larger value. And remember, in our example before, we actually had a difference here of 3 inches. Okay, now down here we had a difference of 8.5 inches. All right, why is that important, and why do we need to know that? Well, what we're trying to do is we're trying to say, all right, well, if you are having a measurement, a difference of something between here and here, that's 16 thousandths at 3 inches, then is it going to be the same at 8.5? Absolutely not. So all we're doing is calculating the shim ratio to figure this out. All right. So here's a line, and I'm going to go over here just to make sure that you can see the line. So we have the line right here, and then we have an angle that goes out like this. Now let's notice something about this angle. We're going to pretend that this is 3 inches. Okay. And then we're going to pretend that this here is 8.5 inches. What do we notice almost immediately? Oh, well, we notice almost immediately that the distance here and here is a lot different than the distance here and here. Yeah, so we're dealing with angles and trig and we don't even know it, right? So really all we're doing is trying to create a ratio between, okay, well, if I want the 3 inches and it has to change by this much, when I go out to 8.5, how much is it out here? That's exactly what we're doing. So how we do that is we're going to follow this whole formula over here, and the formula is this. It's getting a little jumbled up, but we're going to try to figure this out. What we're going to do is we're going to go back to the shim ratio equals the distance 1 divided by distance 2. So it's L1 divided by L2. L1, okay, is what we're going to affect. All right. So in other words, that is the distance between the slots of the motor base. So what is going to be affected? Where are we going to actually put the shim? Where shim go? All right. So L1, that's going to be right over here to the motor feet. So whatever that is going to be divided by where I measured. Where measured. Okay. That's an easy way to remember that. And then whatever you end up with is actually your shim ratio. Okay. So being that said, once we have the shim ratio, then we just need to know what the difference is. So if right here at this point, it equals 0.014, and at this point right here, it's 0.030, then very simply, I just need to get the difference between the two. And the difference is, okay, so when you take 0.030 minus 0.014, you're going to get 0.016. So what we're going to do is we're going to just take the difference here, that how far it went in 3 inches, and we're going to we're going to multiply that by the ratio. So we're going to go times the shim ratio that we've calculated, okay, by taking where we're going to shim from where we actually measured, and then we're going to multiply it by that, and then it's going to give us a value, and that value right there is how much shim that we're going to have to put under the foot. So really, if this is high over here, then we're going to be putting it in, the shim goes in the back. If it's high in the front, then the shim goes in the front. So the shim is going to go wherever the actual value is greater. All right. So this right here is the key that I really wanted to explain a little bit closer. And that is, oh, that's all I need to know. Like if I'm measuring this at 3 inches and it's at the same angle, how would it be? How far would it be at 8.5? Okay. Once you figure that out, then you really got it knocked out.